Very much. So thanks for staying for the last talk before the break. So I will try to be on time. So I want to talk about cultivating data-driven research. So as we do at UC School of Pharmacy, which I'm currently in, just want to give a credit. So a lot of work being done by Cynthia, which is a bioinformatics analyst in the lab. So I would like to start and say that the data is then taking the central stage, and perhaps many people in the room will agree that across the domains, data is shaping and changing the way we do science, and the many questions which were impossible to answer before with pure computational and data-driven approach are actually quite well can be answered right now. So, but I think that's changing the educational needs and the way we should train the students across the domains. So domains which are traditionally lacking the computational training, perhaps that's the time to bring data science culture and data science skills into those domains. So I think we all agree that there is I think one motivation to be that there is overwhelmingly large amount of the data being generated across the domains, enabling novel questions to be answered. And the bioinformatics or the biomedical data science is kind of, at least the way I see that, is the frontier between noisy and large data sets on the left and meaningful interpretations on the right. So that's due to the technology, I think. So we were able to generate tremendous amount of the data across the domains and due to availability and accessibility and scalability of the technologies. So as far we were able to generate millions and millions of samples, which are publicly available. So that's a great resource for the secondary analysis of the data when you do reanalyze the existing data, looking for the novel insights or novel biomarkers and things like that in the data. Okay, so that's happening also in across the domains, including the School of Pharmacy I'm currently in. And I think it's a time, as I mentioned, to change the education standards. At least this is how we see it, the School of Pharmacy at UC, where there is no guidelines how to prepare the students in pharmaceutical sciences. And currently the idea is to outsource that to the biostatistical classes, which we can discuss if it's a good idea or perhaps not a great idea. So, but the current setup, at least at our school, which is I think in many schools as well, where the schools which are lacking the computational culture or the faculty in computational research, they outsource the needs, right? And then they perhaps have limited idea what are the needs, right? And traditionally biostatistical classes were light, let's call it like this, on the hands-on version. So at least the classes which are taught at UC, they include very limited hands-on experience, right? So we're talking about biostatistical kind of concepts, but with the students are lacking real experience with the real world data and the coding skills and things like that. So I joined the UC 3 years ago, almost 3 years ago, as the computational faculty. So I'm only the one computational faculty at School of Pharmacy. So, and I'm excited to kind of launch a change at our school where we would like to develop our own classes at the School of Pharmacy and have that as the alternative to the biostatistical classes, which were traditionally mandated from the students to take. So I think there is a disparity in this sense between the data and tremendous opportunities to use omics data for the discovery and skills the students are having in our schools and many other schools. So as I mentioned, currently there is no way for the students in our school to get hands-on experience. So to address that need, we have developed a class which I will describe in a few slides. And I think that's a kind of an open question, how to do that. So the way we propose to do it, so we propose to develop our own classes within the School of Pharmacy rather than to outsource to the biostatistics departments and biostatistical classes. And the reason is just because we have a full control of what we develop at the school rather than engage in the conversation with the biostatistical class, which I think there is some differences in culture, right? So if you think about data science, which perhaps envision biostatistics to be inside as well as be heavy on the hands-on experience and really working with the data. So the current vision of the biostatistical classes is to primarily provide the concepts and view the data science skills as the secondary. So I think in this sense, we think about kind of either the hybrid biostatistical course or our own course, and the way we think about that. So we would like to propose alternatives, right? So any student at the graduate school, any graduate school student, sorry, in our school will have a choice, right? You either do our own class, which I will describe, or you do biostatistical class, or you do both, right? So you have a choice. Would you rather be willing to cover extensively the biostatistical concepts and, let's say, less hands-on experience, or you would like to focus on kind of balancing biostatistical concepts and hands-on experience in data science? Or you can do both, right, if you're so willing to kind of dive into that field. Okay, so luckily we have a full support from the dean and other people in our school. And actually just recently the dean of school of pharmacy published the vision for the pharmacy education in the future. And I think the big component is data science, machine learning, artificial intelligence, and things like that. So luckily we are lucky to be in that kind of environment, having the full support. And as the pilot, we developed a 2-unit graduate level course to teach reproducible data science to graduate students at the University of Southern California. And then we opened it beyond the School of Pharmacy and engaged people from the medical school and other departments and units. So that was a really interesting experience, which I would like to share, because it was a course from scratch, and we basically were puzzled to choose the language, to choose the amount of details we would like to teach. So it was non-obvious, and we really thought a lot about that. So I'm really excited to share. So this is the course structure we propose. So we basically use the concept where it's actually very interesting that typically when you teach, you think about the teaching something in depth, right? Like you would like to go in depth as much as you can, providing the knowledge. However, here we are dealing with the students being trained, let's say, as the life science researchers or pharmaceutical researchers. So we don't want to convert them to be bioinformaticians or to be biomedical data scientists. So instead, we would like to give them the minimum amount of the skills so that they can do what they need to do. So that's actually a really interesting question. And then you say, perhaps the way at least we see it, like we say, what is the minimum number of skills we can give to them so that they can do simple visualization items like a box plot, a heat maps in the code-based way, rather than, so basically you're balancing between giving the right skills and not to overwhelm them, like not to lose the student, because the opportunity to lose them is just right there, right? They can drop the course and say, that's not for me, that's too much, I will stick with Excel for the rest of my life. So I think that was interesting. So we were really trying to balance. So what we decided to do, we try to minimize the number of concepts and number of things we cover. So for example, we decided not to cover for loops and things like that, but rather focus on the pandas. Take a single library in Python, and we decided to use Python. That's, I guess, was personal choice, because we are, as the lab, we are more comfortable with the Python rather than R. And perhaps I'm on the, my opinion is that Python provides more libraries in terms of data manipulation, and they're more concise, and the structure is better for teaching, but that's personal opinion. So we decided to use pandas and Seaborn and things like that, libraries, to provide basic skills, how you work with the large CSV files and present them as the box plot, or heat maps as the publication quality figures. Then we just allocated two, and remember that was just 2-unit course, so we allocated just 2 lectures to cover basic statistical things, so which you can see here, 4 and 5. And we talk about the version control and how you work with the remote repository, right? Like as you do the analysis, how do you share that analysis? Let's say in the publication mode, right? Like when you prepare data availability statement, where you need to have a GitHub with all the code, with all the data sets being there so everybody can reproduce it. So we kind of introduced that concept that it's important to do transparent, reproducible science, and that's important to share to enable reproducibility of your data. So that's the course structure. So yeah, so I think the primary goal was to teach transparent and reproducible data science, and the approach we took, another kind of challenge, was how we create a uniform environment across everybody in the class, right? So one way is to use a particular cluster, which was presented by the previous speaker, right? So we decided, can we, in this case, we didn't actually need a cluster, right? Because the data sets were quite light. So we didn't deal with the sequencing data rather than some tabular or CSV files. So we decided to use Google Collaboratory, which is a free solution to anybody. And then it's provided a decent level of computational resources. It's a little bit, which I will talk in a second, it's a little bit, there's some learning curve because it's kind of online platform. So perhaps the Jupyter, and then it's actually run on the Jupyter notebook. right? So perhaps the Jupyter Notebook would be more feasible solution, but again, that people use Mac, people use Windows, they use different platforms. So Google Collaboratory was a way to unify everybody. So in terms of advantages, there are many advantages. As I see that, it's accessible, transparent, reproducible, flexible. It's online, so it doesn't matter which laptop you have, and so on. I think there is some caveats, so it's limited by the amount. If you're running large data sets, perhaps you will hit some limit, as well as sometimes, just because it's cloud, accessing the files might be tricky, and especially for the new learners, it was a little bit tricky. So I think in total we got 7 lectures, 5 labs, covering kind of different data sets manipulation, data visualization, statistical analysis, code publication and sharing. We got 1 midterm covering the basic concepts, and in terms of the final, we decided to provide individual project. An individual project was a really large file, right? So we'd like to kind of give more or less a real experience where you have a files of multi-million lines, kind of discouraging students from use Excel, right? So that was the motivation. Okay, so course structure, I will briefly go through that. So we started with the pandas, where we introduced the very, very basic concepts, how you clean the data, how you merge the data sets to tables and things like that, like extremely basic stuff. Then we switched to visualization. I think we covered 2 lectures on that, how you make effective visualization, right? Like what is the box plot, what is actually showing the data points, right? So perhaps you can see here, and what are the settings and so on. So we move more into the visualization. We talk about violent plots, we talk about the heat maps, how you combine kind of the box plots and data points themselves, why it's important to show data points behind the box plot, and so on. So visualization as the tool to present the final results, as well as the visualization as the tool to do exploratory data analysis, right? Which Jupyter Notebook gives a great opportunity, right? You can analyze the data, visualize some intermediate results, which will inform your next step. So kind of giving them that culture that it's not you're writing one analysis, you're done, you're perhaps doing a lot of steps to explore it, and you visualize on the way. We'll talk about extremely basic statistical things, concepts like how to run t-tests, hypothesis testing, and so on. And then we talk about the GitHub. So we talk about what is the best way to organize your GitHub repository. Like, do you put the code and the data together, or do you need to put them separately? And where do you put the figures? Where do you put the notebook? And things like that. So like, what it means to deliver the data, right? To share the data in the right way. So that's an individual project. We gave a file. We tried to be like a real file from some clinical study. The data was simulated. However, it was normal ranges. So it looks like to the students like a real data from the clinical study. And then it was large, right? It was too large to analyze by Excel. So perhaps that was providing some motivation. And then that included all the parts, like data manipulation and it's here. Oops. Yeah, I don't know how to remove it. This is okay. So like data manipulation and statistical analysis and data visualization. So it did include everything we covered in the class, and we gave several weeks, I think a month or even more, for students to work with the data set. And we did have office hours where students can come and ask the questions. So it was really about kind of applying the skills and really working hard to do that. And majority of the students succeed to do that. So we created post-course survey and the pre-course and post-course survey. So unfortunately, we still kind of thinking about the way to collect the data sets, and because we were not allowed to get the names, at least by our IRB protocol, we were not allowed to get the names. So we provided unique identifiers, but some students lost those identifiers. Unfortunately, so we only get like 11 students so far. And so I will only present like self-assessment results. I mean, we also asked the real questions, but that was a pilot, so the course, and we were changing the concept. So the questions we actually envisioned before the course not quite correspond to what we really thought. So we decided to, at least at this stage, not to analyze that. But like we actually converting that class into 4 units class, so we'll do the better job this time. So we got 11 among those 11 students which did not forget the idea. So we got like majority to be master students, and 2 students were PhD students. So I think in terms of self-assessment, sounds like people who were coming, some did have some background in data science, but nobody clear kind of like expect the confidence, like the full confidence working with the data. And as you can see, many were, or majority, I would say, were clearly understanding the concept, how to manipulate the data, how to analyze the data. So that was the case for visualization as well, kind of a similar result. Some people did have some experience, but majority after the class were quite confident. Git repository is kind of the same story, that after the class, people were confident. Some were still confused. I think the Git, we just indicating that we need perhaps spend more time. It's a not trivial concept for people who were not into the field, right? Who were not exposed before to data science. Overall student feedback was overwhelmingly great. So people agree that's an important course to take and high educational impact. So to wrap it up, so that was, we created a 2-unit graded level course to teach reproducible data science to biomedical graduate students at our university. And our findings show that was a feasible solution, and that was I think the right amount of concepts and the hands-on experience that students were overall happy. And we hope that's a framework which can be adopted at other universities, and it's actually, due to Google Colab being the core of it, it's actually scalable, right? So anybody at any university in the world, doesn't matter where, can apply. So there is no kind of restrictions in that sense. So that's really scalable, and we actually plan to extend that and make a proper 4 units course. And that 4-unit course will be the alternative to the biostatistics class offered at the School of Pharmacy. Okay, so that's work of many. So many people were in my lab were helping develop the course, TA, and so on. So I'm extremely grateful for my lab. And we have postdoc openings where we have positions which projects like this, were really interesting educational aspects, as well as like kind of standard bioinformatics, like more scientific approaches. So if you want to live in sunny California, enjoy the views like that, come to work in our lab. Few announcements: we're organizing ISBR conference in Israel, in Haifa. If you're interested to come, that will be November, just before the Thanksgiving. If you want to spend Thanksgiving, let's say, in Israel, that's maybe the conference for you. And I think that's the quote I was finishing all my talks today. So we dedicate our research to freedom-loving people across the world and the people of Ukraine who fight for our freedom. Thank you.
Thank you very much indeed. Have we got any questions?
Yeah, Serghei, that's a nice talk. I want to ask, what was the motivation of the students to take, I assume it's an elective course.
Yes, it was.
Right, so what was their motivation to take it? Were they already doing research and they found this could help their research?
Yeah.
Is that what it was?
Yeah, that's a great question. So yeah, indeed it was a elective course, and I think we got 20 students total, which is quite large for the graduate class. So usually it's like 10 people typically in the class. So we were happy with that. I think for motivation, actually, I imagine it was majority new master students, and actually I got many master students from this class who decided to join my lab, right? But I think students know, I mean, they hear these words like data science, AI, like they kind of have that theme, right? So anytime you talk to them, they're excited about the opportunity of data science in what they do, or like what they kind of studying, right? They don't know, but they don't know what is that, right? So I think it's curiosity. And we try to emphasize really hardly that it's a beginner friendly, you don't need any skills at all. And I think that was encouraging for them to try it out.
So to be clear, these are not PharmD students.
No, they are not PharmD. And actually, that's a great point. Yeah, those are normal kind of like graduate students. But actually, we are planning to make us an elective for PharmD as well this year, this fall. So we'll see how it goes, because I heard from many PharmD students, they're interested in that as well. I think it's a literacy of the data science, right? Like they understand that you need to be kind of familiar with basic operations with data science. That's the future, right? And they say, okay, let me try. And since it's like beginner friendly, nothing is required, look, let me just try it. And many stayed. And I hope that's due to the kind of a nice design of the course. For me, we didn't have anybody drop the class, which I was really afraid that people would be overwhelmed and they say, you know what, I'm going back to my Excel, I will stay there. But that did not happen. So that was encouraging.